So my topic is for today is like robotics in the dark, perception, SLAM, and autonomy from DARPA SubT challenge. So I'm highlighting about the research overview of two teams that got first place and second place in that competition. So the team Cerberus and the team CSIRO Data 61. So welcome you again. Yes. So what is this challenge called actually? So it's like organized by the Defense Advanced Research Projects Agency, like in the past, I think 2018 or 2017. Like that will be mainly launched to like advance in the robotic technologies, like in the operating in the underground environment. So where the mostly the GPS denied spaces to map, navigate, and search complex. Like without sending humans, like it would be too dangerous. So it mainly focused on the tunnels and urban infrastructure, as mentioned in this slide, like the natural caves and like to that the main thing is like autonomous mapping, navigation, and search. And this environment could be changed rapidly, like dynamically, like cluttered or hazardous. And the main goal of them, which to organize this competition, is to get some research overview about two relevant industries that like military, rescue, and disaster response application. So this is Team Cerberus, and this is CSIRO Data 61 team. So what's the competition structure that in that competition? So it's like a system competition and a virtual competition. So in the system competition, they have like they are working on physical environment. So that would be like track A, track B. Track A means like DARPA, some funded teams, and the other one is self-funded teams. So similar to that, there will be a virtual competition as well. So the virtual competition is like focusing on the software based like simulations and other stuff related to the subterranean scenarios, right? So those are the like the competition structure of that main competition. So you can refer on these links as well. Fast, I will upload the slides to you. Like so, these are the top 8 teams. So there might be like many teams were participated at the past, but in the final there were only 8 teams. Like there are top 8 teams are there. But the first two teams got 23 points each. But unfortunately, the CSIRO team got delayed while they are taking a certain step in that competition. So this competition is like tunnel circuit, urban circuit, and cave circuit, and the final event is like a mixed event. And the cave event, it's got cancelled due to the coronavirus pandemic. And how to score in this like in this competition is like to like localization and identify specific artifacts. Like I will show you one of the artifacts in there. Like within 5 meters, they have to like give a report and allow minimum false positive. So I will show you one of the video, like a short video of that challenge for you.
Challenge is about developing and defining the problem, not about defining the solution.
This challenge has the opportunity to create that environment for innovation.
I think that the toughest thing academically about this is having multiple robots work together with very limited human interaction.
You can't just have one thing work, right? You have to have 5 different things simultaneously working. And getting to that point is extremely non-trivial, but I think that that's ultimately the real value.
We love this challenge because it allows us to emphasize on the hardest problems in robotics at the moment, in mobility and autonomy, and emphasize on how to solve them.
We think that the virtual is a chance to showcase ourselves.
So, like this is some kind of a virtual competition. I will explain briefly. Like this is the virtual environment, and this is the physical structure they have built. Like to that the main two structures of that competition, and
where the theory meets the pavement.
So these are the finals that took place the 2021. Like there were many teams are there. Yes, many robots were also there. All right, so let's move on from here. Then, like, I want to talk about the team Cerberus that got the first place of this competition. Like, it has more like many universities and many industry leaders were partnered together, like, to solve this like a complex scenario. Like, there are many universities like University of Nevada, ETH, and University of Berkeley, California, especially the NTNU. So you can search on the Google as well. There are many professors from that university, like focusing on those areas, and University of Oxford right now. And many publications were done according to this challenge, like many, of course, the UAVs and UGVs, and many of them. So let's discuss one of two of them in this learning lecture. Yes. Like what are the contributions for with this like the research overview, like what this team contributed to this challenge? Like they have implemented like some of the versatile robots, and the main thing is like resilient perception and resilient autonomy, and human robot teaming, and the artifacts. So there are artifacts in there. So we have to locate it and detect it. What is this artifact called? And one of the main thing, like I want to highlight, this is a networking, underground networking in a GPS denied environment. So like this is a big challenge. Like they have solved that in a proper way. But I'm only focusing on the perception, SLAM, and autonomy in this learning lecture. Yes. Like when I go through the research papers of that commission, I mainly found that like this is one of the like good paper that they have published. There are many professors in this competition, like in this NTNU professor. Uh, and they have implemented a method called like robust thermal inertial localization for aerial robots. Like it only focused in the thermal inertial localization in a GPS denied and visually degraded environment. So if you have a visually degraded environment, this localization method is like one of the best method that I can show you. And it uses like raw pixel intensities instead of the feature extractions. Like when you have image, like they are only using the raw pixel intensities, like it's mentioned here. Like the main overview of that idea is like detecting the thermal camera and a IMU, and it was like processed in the NUC i7 single board computer, and the post estimate and the IMU data and MPC control for path planning will be transferred to that robot, and that robot will be also transferring IMU data, and we can hit the user commands as well. And it proposed like DJI drone, and they have published about the real world scenarios and real world testing for that. And these are the results that they have published. Like they have compared with the robust visual inertial odometry and their proposed method, and all the methods that they have used, like visual thermal inertial odometry, lidar odometry, and lidar mapping. They all fuse together to get this comp slam. That they have published another paper on that method, so you can refer on that through this link as well to get an idea. Like it like multimodal sensor fusion, like combine all the visual, thermal, lidar, IMU, kinematic data, like a hierarchical fusion framework. Like there is a hierarchy in there, and it's mainly used in the degraded and GPS denied environments, and the visual thermal inertial odometry that I have mentioned in the previous slide, and the LiDAR odometry also there. Yes. And I want to talk about the team CSIRO Data 61. So that team consists with the CSIRO, Emerson, and Georgia Tech University. So like they have got the second place, like the last final artifact they have like find, but the time is going to give some reduce points for them. But the both teams are good. Like they got 23 points in there. Yes, I want to show you one of the video that in the term team Cerberus as well. So this is some kind of a 60-minute, 60-minute, yes, 60-minute one, but it's only 2 minutes right now. Like they have attempts, like 45 attempts and 28 sectors to explore. Like they have exploring and the attempts were there and the scoring system will be there. Like they have to detect the artifacts of that visually degraded environment. So there might be smoke and other stuffs will be there. So that's how the 23 points scored that team. Yes, I think you have idea what the point system of this competition. Yes. So related to CSIRO, like there were many robots that they have implemented on this challenge. Like there are drones and there are quadrupeds and there are UGVs and yeah. So many sensors were there, like the immersion sensors. You can search on the Google as well. Like there are plenty of like good sensors are there with that pen. Yes. So those are the things like they have mainly focused on the robotic, like the robots and the SLAM systems. So let's talk about the SLAM system. Like as I already explained in the past learning lecture as well, like the CSIRO Wildcat multi-agent SLAM is the best one that they have proposed in this challenge. Like it's like building a global map by only local available data. Like when we talk about the SLAM features, like it generated 5 seconds, like the frames will be generated every 5 seconds using 6-second multi-sensor data, like the LiDAR and IMU will be fused together. So those are the things like they are, and the one thing I like the contained compressed features, like not about the raw data to reduce the bandwidth. So when we transferring data with the others, there should be the like a bandwidth issues, but the shared with the other agents as well to get the collaborative mapping in this competition as well. And they have used the express graph construction, that the graph construction method that they have used. And these are the achievements that they have without getting the second place, but they have published like the submit artifact report. They have to submit it, and the submission XY Z coordinates and the type of that. So the real one is 21.445, but they have submitted like 21.49. Like only a small delta value is like incorrect, and the error is like this way. And you can yes, so they want the single most accurate report, like they have to submit those reports. Yes. So that's about my short review of that competition. So if you have any questions, like let me know. Right. Thank you for listening to my learning lecture.